Welcome to this video where we're going to go through the answers to page 23 of the Forces booklet, Scalar and Vector Quantities. So, in question 1, in the grid below, each square represents 1 Newton of force. State the size and direction of each force arrow. Well, we can clearly see here that arrow A goes from here to here, which is 1, 2, 3, 4 squares. If each square represents 1 Newton of force, then this will be 4 newtons to the right. Let's have a look at B. B starts here and finishes here. So it's 1, 2, 3, 4, 5 newtons, but this time to the left. C is a bit more tricky. It's clear that it goes up and to the right, but what's the value of the arrow? We could work it out by measuring it. However, there is another way. We can also recognise that this is a right-angled triangle. We know that this line here is 4, and we know that the height here is 4. So we can use Pythagoras' theorem that 4 squared plus 4 squared equals the length of c squared. If we work that out, we find that c equals the square root of 32. 16 plus 16 square rooted. So we know, rounded to one decimal place, it's 5.7 newtons up and to the right. Question 2. The grid below shows a map with 4 towns on it, and the map is to scale, where each square represents 1 kilometre. A delivery drone must travel from A to D, passing through towns B and C first. So it must be going this way. We need to assume that it travels in straight lines between each town. Draw a vector arrow to show the displacement of the drone between each town. So it's telling us the route from A to D via B and C. So our arrows, drawn straight, will look something like this. We now need to calculate the total distance travelled by the drone. We're going to need a ruler to measure the length of each vector. So we know that each square represents 1 kilometre. We can see here that 1 kilometre equals 1.4 centimetres. We can use this ratio to work them out. So measuring the distance from A to B, we get 10.5 centimetres. From B to C, 4.5 centimetres, and from C to D, 4.5 centimetres. We therefore know in total the drone has gone 10.5 plus 4.5 plus 4.5 centimetres, which equals 19.5 centimetres. If we want to convert this into our actual values, we know that 1 kilometre equals 1.4 centimetres. So we need to know what is represented by 19.5 centimetres. The easiest way to do this is to think about what do we need to do to get from 1.4 to 19.5, and we need to do the same on this side. To get from 1.4 to 19.5, we need to times by 13 and 13/14. So we need to do exactly the same on the other side. So if we multiply this by 13, 13/14, we get 13.9 kilometres. Another drone travels directly from A to D. Draw a vector arrow to show this displacement. So it will travel directly from A to D, and it will look like this. State the size and direction of the displacement from A to D. So again, we need to use our ruler to measure the total length, which in this case is 6 centimetres. Again, we need to use our scale to work this out. So we know that 1 kilometre equals 1.4 centimetres. We want to get to 6. So what do we need to do to get from 1.4 to 6? To calculate this, we'll do 6 divided by 1.4, which gives us multiplying by 4 and 2/7. So we need to do the same on this side, which is 4.3 kilometers. For our direction, we could say up and to the right. And there we have the answers to those questions.